Hello, hello, and potentially welcome to this stream here. So I've been advertising that I would do a 500 sub celebration video. Um, yeah, so let me just see, just a sec. Uh, this one will be set here because I need to set up some stuff. Let's see. Okay. So the general idea is that since I like editing, um, I'll do what I've done before, and that is record the video during some live streams. So if you ever wonder um, what went on between episodes, um, uh, let's see, then you would know that you could find the whole thing on the live stream here. Okay, so let's create an outline here. Um, so tutorial series update. 500 sub celebration. We'll expand on the toon shader implemented in the last series, and um, we'll start out by implementing some different stuff. We'll use the FBX SDK. We could use AmGUI. I'm not sure we really need it. But the FBX SDK makes us able to kind of like do model loading, which the project doesn't have. And then we should do some, I guess, some shadow mapping. And then maybe some frame buffering, and then a and let's do deferred rendering. Potentially frame buffering. Yeah, I think we will do frame buffering, deferred rendering, and then outline shading. Yeah, I think this is an interesting roadmap. Maybe even do deferred rendering first, and then do shadow mapping afterwards. That probably makes more sense. So let's do episode 1/28 and so forth. Okay. I actually think this is our outline. And yeah. That's what we will do. Okay. And as of last time, I'll do some recording during the stream. So yeah, I won't be tending to chat in between. Okay. Let me just get set here. Yeah. Let me just do a short introduction video. Maybe I should free FBX models. Okay. I'll update the thumbnails eventually. Okay. Let me just record the introduction video. Hi there, and welcome to the tutorial series on C++ and DirectX 12 update. Since I've reached 500 subs, I promised to do an extension of the tutorial series. So we'll be doing that. We will be expanding on the toon shader that got implemented in the last series. I record these videos during a live stream, so if you're ever in doubt on what happened in between episodes or want follow up on some of the questions that got asked, feel free to check out the live stream in the library. Um, um, always, if you want to support the work, consider um, commenting, liking, or subscribing, or checking out the description down below um, if you want to support the channel. The source code for this tutorial series will be available on GitHub. And also, I realized that we had a bug on the GitHub repo. So if we just access it, you'll see that I updated it a couple of hours ago, and that's because the GitHub ignore file actually ended up including this folder here. So it didn't exist in the repo, so I updated that. All right. The first thing we'll do in this series is to update, or rather implement the FBX SDK, which will be our first episode. So this gives us access to model loading and potentially material loading. Next, we will implement some deferred rendering. That is something that we will use to do our outline shading eventually. Deferred rendering is probably a nice way to um, do toon shading, since we're not gonna do a lot of different transparent stuff. Instead, everything is going to be toon shaded, and yeah. So the deferred rendering pipeline is pretty interesting in that regard. And after that, we will do some shadow mapping. Uh, I'm not sure whether we will do the frame buffering because that's an optimization. So I'll leave a question mark here, but then we will try to do some outline shading, um, uh, which is going to be in screen space. So this is the outline for the coming episodes. Yeah. So hopefully you'll find it interesting or helpful. Yeah. Um, and if you do, as I've mentioned before, please consider supporting the channel. All right. Hopefully I'll be seeing you in the next episode. Bye bye. And here on the live stream, I'm gonna upload the video. Let's see. Let's see. And let's create a new playlist. Let me see. Let's open a notepad. Let's see. Okay, I'm just messing around with that. Let's see. So let's see. Okay, and mm, mm, hello, C. Uh, let's see, and then let me just see. Okay. Let's see. Autodesk FBX SDK. Okay. And let's see, let's update that as well. Okay, so I think I have a description now. Okay, let's update the YouTube page then. Yeah, I'll update the thumbnail eventually. New playlist. Let's see. Uh, no. Let's see. Okay. Done. Let's see. Okay. I think I got the video published. Hi, Mr. Yes. So, yeah, I just published the first episode of the Toon Shader series update. Okay. Um, I'm doing all right. Just recording the tutorial videos, so I'll be going silent in a moment. Right now, I'm just, yeah, I just uploaded the first video. Um, and I'm gonna do a bathroom break real quick before I continue recording the first video here on this series. Okay, be right back. you. Should be somewhat straightforward, at least some of it. Let's see. Uh, let's see. So yeah, maybe I should just get at it. Do the first tutorial part here. Uh, let me see, let me see, let me see. Yeah. Okay. I'm gonna start the recording, so I'm not gonna see chat before I end it. All right, hi there, and welcome to the first real episode here on the Toon Shader tutorial series, which is getting an update since we reached the 500 sub celebration. Be sure to watch the outline video for this series. This is the episode where we implement the FBX SDK, which will be our only dependency so far. I think that um, this gives us some more utility in terms of actually loading FBX models and making our renderer behave more interestingly. So we will do that, but first we need to actually uh, create a project. I'll start out by clicking continue without code, and we will actually clone our repo by using the git changes. And we will uh, grab the clone here. And let's see. And let's see, as you can see, I already installed the 500 sub. Let's do that. This is going to be my path, and I'll clone it. And if we're lucky, everything runs. Oh, wait a minute. We of course need to set this as our startup project. The application needs to be run. Let's see, set a startup project so we don't try to run a DLL. There we go. So this is where we left off. Everything should build on your end. I actually discovered a bug in the last episode, or rather the GitHub repo, where the debug folder didn't get uploaded to our repo because Microsoft decides to ignore all folders called debug. Anyway, so this is our setup. Um, let's see. I want to see the folders, and everything is running, building accordingly. So what we want to do is, uh, let's see. Oh, whoops. This was a video from before. So let's just do just another bad programming guide. And let's see. And whoops. I'm sorry. Um, let's find the FBX SDK link here down in the dependencies. Of course, you should download it for Windows. I'm using Visual Studio 2022, so therefore I have that version. You will download an installer, and you will have to decide on a directory. So what I did is I installed it on my G drive in a libraries folder and in the FBX folder. And you can follow the documentation here. I'll of course show you how to do it, but installing and configuring, we have different stuff for Windows and Linux. We will be using the static library stuff, so it gets baked into our project. This is then how to implement the different stuff. So let's open our project here, and in properties on all configurations, C++ general, I'll add the include directory for this library here, FBX, and it's of course in the include folder. And I add that to my include directories, and of course I make sure that we're doing it for all configurations. Then this project is set up correctly, but you have to check the code generation flags for your compiler. So you can see it's multi-threaded debug DLL. That is our runtime library, and for the release it's the multi-threaded DLL. So no changes are needed, but as you can see, these static libraries here actually require different runtimes, and depending on your Visual Studio version, you might see different options in terms of the runtime library. So make sure that you are having the correct what do you call it, runtime libraries according to your version of Visual Studio, if you're using that. Otherwise, I expect you to be able to actually be able to what do you call it, figure out the correct installing of this library here. So then in our linker, we need to add our library dependencies. And let me see. So in our linker here, all configurations, let's do input, let's do additional dependencies, and let's look into our FBX library here. And in lib, we are working on an x64 platform. And these files are named the same for either debug or release. But we would want it to select the correct configuration. So we need a macro that we used in our setup here. So we actually have these macros here that allow us to select our platform and then our configuration. So for our additional dependencies here, we want to add this. So for the debug configuration, we would end up with something like this. But we of course want to specify the what do you call it, path here. So we would have to add this before. So this evaluates to this path here, and let's just check whether we can actually look up that path. We can. Okay. Let me see. And let's see. Yeah. Oh, maybe I'm actually entering this in the wrong one. Let's see. Yeah. Let's do it in here instead in general, but it's still the same thing. Okay. So we add this dependency here, and then in our input, we can actually add our specific files. Now, I'm gonna use the one called MD here because that was what my code generation was using as flags. So remember this section here, runtime library, it's MD here. So I'm gonna use these file names here. I'm gonna add the SDK md.lib. And let's add that. Let's also add the libxml2 library. And let's add the setlib as well. I'm pretty sure we use that one. But we need the one that is, of course, with the MD tag here. And then, as you can see here, we need an additional dependency called this win inet or whatever. So we add that dependency too. And then since we're using the static oh, it's only the oh, it's actually only for the debug version. Okay, so let's apply that, and then in our debug version we will add the thing here, and then we need to ignore a default library as well. And that's our debug setup. Okay, everything should still compile, hopefully. Yeah. But right now we're not using anything, so that might be our salvation. Anyway, so let's try using our code here. Let's see, or rather library, the FBX library. And let's create a new engine file or folder. Let's see, model loading or something like that. And let's create a class. And let's do a model loader API. And let's do this, add a namespace, and of course we need, let's see, and let's add the export function here. Or maybe, yeah, let's just do the export. And then let's just create the default constructor here. And then in our renderer API, let's include it, model loading, model loading, loader. And of course, we'll move it so that we can actually find it. And let's do a private here, model loader API, model loader. Yeah. And then inside this, no, rather this, let's see, engine. Let's actually include our FBX SDK header file. And then let's do a void load FBX model const char pointer file path. And let's create a definition for that. And inside our renderer API, right now we're doing all this. We're actually creating the meshes and stuff like that. So we're uploading our shadow transforms. Let's remove this. Okay, so let's try accessing the M model loader, load FBX model, and let's create a folder here. Models, and let's create a Blender model for it. And let's see, we'll load a model, but first we will create one. So let's open Blender. Let's build a interesting model here. First off, let's delete the camera and the lights since we don't want that. Let's enter edit mode. And let's just build a model. I won't be creating anything complicated, but I just want something like this, and maybe scale this down so that we can actually have something that allows us to okay, this is our model. It's very, very great. And we will export it as an FBX. And then in our YouTube repo, application models, we will model, or rather test. And let's I can't remember. Let's see. What is our camera actually set up to be? So our camera, when we create it, our camera is it right hand or left hand side? I can't remember. Left hand. Okay. Yeah, so I think this is the positive set is forward. Okay, and I'm not gonna do any settings here. I'm just gonna export it as is. And now we should see our test.fbx here. So in our renderer API, we will do models test.fbx. All right. And then inside our model loader here, we will create a FBX manager, pointer, manager, which will be created by a FBX manager, create call, which creates a pointer. We need to set up some input and output settings. That's also a pointer. And we will use a method for that as well. We will create, and it will take a manager and yeah, input output settings root. Look up the FBX documentation if you are in doubt. And then we will set the input output settings into our pointer here. Let's create an FBX importer then. Yeah, so this is a memory manager. This is settings. This is the actual importer. Importer. And let's give it our manager. And then the name, FBX importer. Let's just do that. And let's do a test here. So if our importer here initialize with our file name here, file path, file path, and our format, and our manager settings, get IO settings. If this fails, we probably need a parenthesis. We need to pass out a error. Let's see. Can't remember how this project actually uses error handling. In the debug, let's see, factory. Okay. Yeah, so YouTube eval, it uses cout. Okay. And we have print. Okay, we can print messages. Okay. Model loading failed. Print in error code. And then we pass in our importer here. Get status and get error string. Yeah. Okay. Else we do something like print success loaded model at and then file path here. And let's see. Let's check our output log. Success loaded the model at models test.fbx. So far we're good. Then FBX models are arranged in scenes. You could actually import the camera, the lights, and everything with this SDK here. We will only use it for models and maybe even material settings. But yeah, we won't be using those features. So let's build out this function then. So let's create an FBX scene. Where we do scene and we do the usual create stuff here. Create, not create character. You can do all different kinds of stuff. You can also export FBX files with this interface. So therefore it's loading scene, model loading scene. And then let's do our importer here. Whoops. Import. And let's do scene here. And then we can deallocate the importer. And then we can start getting our mesh. So if we have several meshes here, we might want to be able to iterate over them. So let's say that we do something like let's just do an iterative loop here. Int I 0 I less than the scene get geometry count, and then let's see, geometry instead maybe. Let's see. And then we simply want to maybe print geometry number and then our geometry number here. And can we do anything interesting. Maybe +1. And let's try to get a mesh. Let's see. FBX SDK. Create mesh from geometry. Scene geometry. I think this is this still relevant? Oh, anyway. I think the information is yeah, let's see. So we want to do scene, get geometry. I can't spell. So let's get some help. Geometry. And we get the index here, geometry here, and it will return an FBX geometry. Yeah, the FBX mesh. Let's see. Okay. And if we do, yeah, right now, IntelliSense is going nuts. Let's see, mesh pointer here. Yeah, so this inherits from it inherits from so the geometry will have the base data. Yeah. Okay. So we can basically do this mesh equals static cast FBX mesh pointer, and with our geometry here. And this should be fine, right? Yeah. And maybe IntelliSense needs a refresh here. Okay. Let's help IntelliSense recover itself. Oh, this is the wrong version of Visual Studio. So there we go. So we have our mesh. And then we can, for instance, pass out the vertex count, mesh it, and this is called control points, and print in index count, and this is called polygon count. No, not polygon count. It will not be the total index, but it would be something like polygon count here times mesh get polygon size. And let's see. This should be, isn't it fine? Oh, I need to put it in a parenthesis, I guess. Or what? Am I not allowed to do that? Oh! Let's just do a normal polygon here. Yeah, okay, the index count is not correct, but as you can see, we have a vertex count of oh, maybe the index count is correct. I don't know. Could be. Anyway, we have 32 vertices, and yeah. So let's do some more model processing here. Right now, in our renderer API, we have vertices, and we basically want to replace all of this stuff here. So we have vertices with a normal and position, and then we potentially have some indices which are just unsigned ints. So let's expand our model API here with a std vector of vertices, reference out vertices, and a std vector of unsigned int, reference out indices. And I don't know if we need to include the renderer data types. Yeah, we do. Let's do include renderer API, renderer data types. There we go. And we need to, there we go. Okay, and let's add that. A comma too much. Anyway, okay. And then in our calling function, let's eliminate this. So this is the vertices so far. Let's see, let's not upload anything. Actually, maybe just comment out the whole, oh. Also move this, I guess. Yeah, so let's comment out this and rather right now we need to fix this. Okay, and let's move this. Yeah, so we have our vertices. We used to have an array. We will create a vector here, indices, and pass in our vertices and indices. Then we can re-implement our code here. Let me move this up here and then copy this. And we'll fix it in a moment. We'll just also move this down to the end of the file. And let's do this. Oh, I forgot the initialization of it, right? No, I initialize it up here. Okay. And then yeah, we need to fix that code. Yeah. So, whoops. Let's arrange these things separately. So we have our loading here. Load our FBX model. And then we want to upload our vertices dot data. And let's do vertices dot size here as our total size. And then we can upload that, and then let's do like this. Whoops, data. Okay, it actually wants this type here, so let's just do that. Just let's make sure that it's actually the same type. It's 32-bit instead. Okay. And let's do indices.size. Yeah. So we have our index buffer, our vertex buffer. Let's see. Let's just do 3 indices for now. We will, of course, create something that is way more dynamic. And let's see if everything compiles. Yeah, right now we're not rendering anything. So we could store our, right now we don't load any data, so that's actually our problem here. So let's start loading our data. So for each geometry, we want to create a const fbx vector here, or rather, first we want to create the vertices. Let's do a for int I 0, I less than, and then our mesh here. Get control point count, and I plus plus, and then fbx vector 4 reference position, which will be our mesh. Get control point and let's build our vertices. Let's do a render vertex. Let me just think. So let's check our normal stuff eventually. So right now we're gonna do vertices here. And let's do vertex dot position. Yeah, let's do that as a start. Right now our normals will not be set, and I'm considering how to grab them. Let's see if we have any errors doing this. Anyway, the position is a DirectX float 3, so we can initialize this as our position X component, Y component, and C component. And then we can actually push back that to our vector. So out vertices dot push back, or rather in place back vertex here. And let's try running that. Okay, we have a problem. Yeah, so this is probably a double. There we go. And let's try building the release as well. And then we want to copy our resources here. We have our models. We actually need to copy all of it to debug it. So we need shaders. Let's see, we should be able to run this application here. Yeah. Loaded geometry and so forth. So now we can use, let's see, NVIDIA Insight here. Does it work with this build here? I can't remember. Let's see, Insight. Let's try that. Let's see. Let's capture a frame. We have a frame capture here. Let's see, all resources. Let's do a lookup in our vertex buffer here. And how is it? I can't remember. It's been so long since I actually. There we go. So float 3 and then float 3, I guess. Right. So we have some vertex coordinates here, which looks fine, and then index 32 indices. So we actually upload our stuff here. Okay. So that's great. Let's close all of this. So let me see. Let's see if we can actually grab our normals as well. So let's see. Let's test something. If the let's see, mesh normal get normal let's see let's see, get element normal. Let's do an pointer here to this FBX FBX geometry normal, rather element normal here, normal, and we will have a index of 0. It's fine. It's just grabbing the first one, and we can do get mapping mode. And if this is, let's test, if this is equal to FBX element, no, is that it? Can't remember. Geometry element, FBX geometry element enum by control point. We have normals on the control points. And we don't. At least so it seems. Maybe it's in Blender when I export to FBX. geometry, smoothing. Let's see. Then we would want to actually recompute some normals manually, since our system is using a kind of like um, creating extra vertices with the specific normals. Yeah. Yeah. Can I convert it? FBX SDK convert normal control point. Let's see. Okay. Let's see. Anyway, we'll have to recompute the normals and potentially create the correct vertices. So instead of doing this, we have to do something else. Let's create the normals and indices here. So let's do that. So this will be our renderer vertex here, vertices, and we will reserve with our control point count here. And then we will do a vector of uint 32 indices. So far, let's do something like this. We won't be adding anything. And then we want to do a for loop here as well. No, this is outside of this loop here. So this is going to be here, and this is going to be here. And then we process the base vertices. Actually, I think this should be maybe even just a DirectX XM float here. positions. And then we will recompute our normals here. So instead of doing this, we will actually do a DirectX exempt float here, position dx, and let's do an in place back of this position index here. So we store our base vertices positions, then we want our thing here to actually process our indices and normals. So let's do mesh get polygon count. This is the amount of faces we have. And let's do polygon here. Polygon and increase the polygon. And let's do a const unsigned, or rather a const int polygon size. And let's do our mesh here. Get polygon size. And let's just print it out for now. Poly size. Polygon size. And let's comment this out for now. And let's do for the polygon. And let's see how our faces is arranged actually. Okay, we have 4 polygons. Yeah, so maybe we want to actually remember when we export our model here. I'm just going to use the cube instead for now. It won't matter. Let's do the correct directory, of course, here. And then in our application, we will overwrite this. But when we do geometry, let's do triangulate faces. Yeah. And let's remember that our X set is going forward. And let's export our FBX. And let's try loading then. And we have a polygon size of 3 instead. So right now we're rendering triangles and not quads. Therefore, I do that. Can you set polygon or convert? Yeah, maybe you could use the FBX library in a smart way to do conversions for you. I can't, I really don't know the SDK that well, so I'm not gonna spend time, you know, diverging down that path and exploring um, exactly that. So let's do vertex list then. Oh, let's do polyvert, list and polygon size, and then polygon vert here. Polyvert plus plus. Um, And we want a index count here, total indices, which is actually going to be stored outside of our geometry, rather like this. It's because we will do unsigning total vertices. I guess we could use that as well. So now let's not do it here because this is temporary. So total indices plus plus here. Okay, and then we will do a uint in index, which will be our mesh get polygon vertex in our polygon, and then our polyvertex, and we will add that to our indices list. Pushback, or yeah, we could do in place back, although it doesn't matter. This is not constructed in place anyway, and we'll do that. Also, we want some normals. We want some normals, which are xm float normals, polygon normals. Yeah, so we will want to process our polygon, or rather our normals here. So for we will create a normal here. Normal for normal vec4, which will be our, let's create a function for this. Get normal. Return fbx vector here. And let's pass in a mesh get element normal. So we will pass in a normal here, which is great. And then let's see. So we can pass in our our face index here as well. Const uint 32 face index. And let's just do some error checking here. If the normal mapping mode and it's not equal to FBX geometry geometry element E by polygon vertex. If it's not, or rather, if it's like this, we will handle it. Otherwise, we will print in not implemented normal handling for other than face indexes, face indices. Okay. And if the normal reference mode here, get reference mode is equal to eDirect, we do like this. We simply return the normal get direct array, get at our face index here. Otherwise, we set our const index to be our normal, normal get index array rather. Get at face index, and then we return our normal let's see, normal get direct array, get at, and with our index here. Let's just do a temporary output here, non-direct mode for normal. So this is processing the normal, and let's see if we actually compile and run, and nothing happens. That's because we actually do the direct. Okay, let's do direct mode. Yeah. Okay. Yeah, so we can directly access the indices and don't have to get a separate index from the index array beforehand. Right. So this processes our normals. And let's do const here. And then let's create our normal. Let's do DirectX xm float 3 normal vec4 0 1 and 2. That's our normal, and then we add it to our polygon normals and place back our normal. Yeah. Okay, so now we've created all our information for this thingy here. So now we have our arrays. We create the vertices and then create indices and normals. And then we have a problem still because our normals um, so we kind of like have more normals um, than we actually would like. Let's see. So the vertices themselves are like empty. They don't contain any normals, but the indices control the normals. We could do separate buffers. I don't know. Um, so let's just try to debug this and see what information we get. Loaded model. Oh yeah, okay, I need the float. Okay. Let's see. So let's see, we have our polygon normals. We have 64, we have 6, or that are rather 36. Let's see our indices. Yeah, and our normals here. Yeah, so let's see. Mesh get polygon vertex normal. Uh, let's see. Uh, I guess we could build our um, polygons from this. Um, let's see if we export it. Yeah, so yeah, so um, yeah, the problem is that right now we're getting um, 36 indices and normals, since the normals map to the uh, FBX SDK, the normals map to convert normals to control points. Let's see. Mm, let's see, Blender, export, FBX, normal with control points. Let's see. Okay. Vertex. Let's see. Let's see if we let's see. Well, I guess yeah, I think I'll add this in part 2. So yeah, there will be a part 2 in terms of figuring out how to actually do this most elegantly. Since our DirectX backend uses a different vertex format, we could solve it in different ways. You could upload the normals to a separate vertex buffer and bind 2 vertex buffers. But our indexing here gets wrong as well. So, or rather, maybe okay, let's just create a separate thing here. Normal indices. Let's do a uint2. This is actually 32, right? Index 2, mesh, get, polygon, normal. Can I get the index? Oh, wait a minute. So that's actually, I think, also, am I supposed to? Yeah, so we get the element normal. Yeah, maybe we can grab it from that. Let's see. Our normal pointer here. Let's see if we can test normal. Get owner. Remap index to new mapping mode. Oh, let's try that. Remap index to. Yeah, let's try that. Remap index to. FBX layer element by control point. And let's see. what we ended up with that. Still 36. Oh, yeah, okay. Uh, let's pass in this then. 36. No. Yeah, I'm gonna play around with that and figure it out for the next episode. So at least we got our models loading here. Uh, we still need to actually upload it to the GPU and use it in draw calls. So I'll do that in the next episode. All right. Yeah, I'm doing this live, so bear with me in terms of actually discovering different problems. I haven't worked a lot with the FBX SDK, and I, in my other projects, have implemented a model loader myself. So um, it's just the way it goes. Anyway, hopefully I'll catch you in the next episode. Um, let's just do uh, extension part 1, yeah, and commit these changes. And yeah, feel free to comment, like, or subscribe, or check out the live stream where we mess around with this stuff and answer questions. Uh, yeah. All right. Hopefully, I'll see you in the next one, and bye bye. And hi, guys. Uh, um, so I haven't really been intending a chat. So linguistic mirage. Why don't I use NVIDIA's? Because I don't want to. I see absolutely no reason to. Uh, uh, and Julian, I know I never sleep, and Echo the developer. Yeah, it's a tutorial. Uh, I want disable chat because I don't think it's important what we see, and people can always look at the repo. Okay, let me upload the video here, and let's try to figure out. Uh, let's see. Let's see. And I don't know if I have anyone with me or if I'm all alone. Uh, oh, I'm all alone, it seems. That's fine. Okay, I'm gonna mess around with this model loader stuff here. FBX SDK remap normals to control points or create. Let's see, calculate normals is FBX SDK here. Mm. Yeah, we could just do let's see. So let me stop here. The normals. Mm. Let's step into this. And the end test here. Index array, direct array. right. Let's see. Let's see. And in our function of here, let's see. And test it. Let's do fbx array, fbx vector 4, data. Okay, 16. Let's do const reference here. Let's do const auto. Yeah. So our data, okay, the data is 0. Huh. Mm. Why is this not actually set? Let's see. Is the implementation actually at watch? Huh. Uh-huh. Okay, let's see if it actually changes anything. So let's see our data here. Oh, it returned -1. Mm. And test remap. Let's do FBX SDK. Let's see. Let's see. Let's do const auto ref mode. Whoops. Polygon vertex, ref mode, direct. Okay. Just gonna do a bathroom break. No, well, I guess you need to decide on what you would actually want to do. Um, I'm gonna record the next episode here. Um, yeah, okay. Hi, and welcome to the next episode in this tutorial series where we implement the FBX SDK and do some follow-up on the renderer in this series. As I've mentioned, these tutorial videos are recorded during a live stream, so sometimes accidents happen and uh, we don't end up in a totally working state. But um, we'll give it a try. So last episode, uh, we got the model loading using the FBX SDK. We implemented it. We implemented it in a somewhat naive way here, but we will do something else in order to actually load this stuff here. So let's comment out a lot of this stuff here because we will redo bits of it. Yeah, so let's see. Let's do a const int face count, which will be our mesh get polygon count here. And we will do a FBX vector vertex positions and this returns a array. And let's do a const int vertex, or rather, I'm not sure whether we should call this control points and then just to use the get use the terminology used by the FBX SDK. Yeah, and let's do an unsigned int. And let's do a polygon iteration here for all of the face counts here. Maybe even just a face plus plus. And let's do a const face vertices vertex count. Let's do mesh get polygon size for the face here. And then inside that we will do int face vertex and face vertex less than face vertex count here, and then face vertex And let's do a int const int control point index polygon vertex, add our face and face vertex here. And let's do a let's do a render vertex here. I think vertex. So the vertex position should be let's see. Let's do const reference position data equals control points. Let's do control point index here. And let's do a position here where we, of course, cast to float position data 0, 1, and 2. And let's do a const int normal count get normal, rather get element normal count, and then int normal count here, and normal element plus plus. Oh, I forgot this as well. Okay, and then let's did we, yeah, let's see, normal key normal. Let's see. And let's get the normal. Let's see. Let's see. So we want to let's see. Let's see. Let's grab our normal. Let's see. Normal data here. Get normal, p normal here, and let's use our vertex count here. And then we set our vertex dot normal equal to something like this, but with our normal data instead. Yeah. So, and then we have our vertex. Let's do a series of uh, um, data structs here that rather contains our uh, um, let's create a vector here of our vertices, mesh vertices, and let's do, we find the normal, and this is outside the scope of this, so this will contain the actual vertices. Then we check if the current vertex, let's see, let's do a const size t mesh vertices equals mesh mesh vertex count dot size here, and then do a for loop here, int, or rather size t I equals 0 and 0, or rather I less than this mesh vertex count here, and then I plus plus. And let's see if we can create a function here. Bool compare vertex render vertex reference A render vertex B here, and if A dot position, can I do this? B dot position, can I compare them? No, I can't. DirectX Math doesn't have a comparison for this, so let's do x equals x. Let's do the same thing for y. And let's do the same thing for c. If, then all of this, instead of the position, we do normal here. Then if this is the case, we will return true, otherwise we will return false. So we simply check if these vertices are the same, and we will then check if compare vertex. Let's see. Oh, this is supposed to be inside here. Vertex and mesh vertices I. If we have it already, we break. Oh, we want to and make sure that this is 0. Because if we find a vertex, it's not unique, and therefore we will break this loop, and then we can check if the I ever reached the mesh vertex count. And if it did, we will do mesh vertices, push back, or rather in place back our vertex here. And then let's also create a vector here, uint32 mesh indices, and I think it's just the face value, right? Yeah. I suspect, or rather, no, since we computed the I, it's of course that one. Okay. mesh indices dot pushback the I value here, and then vertex, or did I vertex plus plus, right? Yeah, so okay. Let's see what we end up with. And let's try removing all of this. Oops. And let's see. Okay, so we have mesh vertices and we have mesh indices, which looks like something that we actually want. So we now have computations of our unique vertices, and we can simply move. Right now it doesn't support it. It only loads one geometry, but I leave that to you as a potential fix. So out vertices equals to std move mesh vertices, and let's do out indices move mesh indices. There we go. And immediately you see two triangles here. That means that we actually have created some data. Should we implement several meshes? Okay, let's couple this to the actual renderer. So the model loader should return a set of draw parameters. Yeah, I'll leave the implementation of the extra models until later. If you want me to do it here on the channel, feel free to do that. Maybe we want. Okay. So what we'll do is something like struct mesh draw data, which will be a maybe a uint32, just to keep our stuff in the same order, I guess. uint32 vertex count, uint32 vertex offset, uint32 index count. Let's do index offset. Yeah, and our renderer API here will actually have a vector of meshes, mesh draw data, mesh meshes, which we will then actually pass as an argument to our model loader here. Out meshes. And we will pass out the meshes here. Let's do. Is this in renderer? Yeah, I think so. Render. Yeah, so. And let's see, this is our mesh, right? No, this is our mesh. So this is actually what we want to. Oh, yeah, okay. So this only right now supports one mesh. Let's see. Just a sec. Let's see. So, yeah, we want to compile our mesh data here, render mesh data, and mesh draw data, which should be the. Okay, maybe I should just implement the multiple mesh stuff anyway, and as we're currently doing it, so mesh vertices dot size mesh draw data index count mesh indices dot size. And let's do a value so it's not related to this. So outside this we will actually do something like total vertices uint 32 total indices. Let's see. Let's do an unsigned, or rather maybe a size t. Vertex offset and size t. Index offset. Yeah. Usually we don't need. Oh, the vertices. Oh, yeah. I think we will need both. Index offset here. And let's do the draw data here. Let's do index offset. vertex offset. Let's move this. And at our out meshes, we place back this mesh draw data here. And this will simply create our draw calls. Let's do total vertices. Whoops. Total vertices. Can I do? Whoops. Oh, I have. Oh, I don't use these. Insert at the end of the end here, and then let's do mesh vertices that begin, mesh dot vertices dot end. Right, and let's duplicate that for our total indices, and let's do mesh indices. There we go, and this should actually okay. So this should actually allow us to load several models in the same Blender file or FBX file that is. And let's see, let's do mmeshes. And let's do this. Okay. We have some trouble. Let's see. Render. Oh, I need to actually specify the namespace here. Okay, so we have on our render API here, we have our meshes which are 0, and now we should have 1 with a vertex count of 24 and index count of this. So let's do a implementation down here when we do our draw calls. Yeah, so let's just access. We need the, let's convert this then. Draw index instance count per instance. Okay, let's do meshes. And let's grab our first mesh here. Let's do index count here then. Instance count is still 1. Start index location meshes. Maybe even let's do render draw data pointer draw data equals this, and let's do draw data index count, draw data index offset, um, vertex offset, and then the start index location, or rather instance location. And let's copy this for our draw calls here. Okay, let's see. And we're back to rendering boxes. The normals are apparently flipped though. Let's try swapping the winding order. So where do we create our pipeline? Our pipelines. Let's see, pipeline here. Let's do false for this, maybe. Yeah. So the winding order was wrong. And let's see one more cycle. Yeah. So this basically uses the FBX SDK to load our models now. We could, of course, do something more interesting with it, but rather than a cube, let's try actually, well, yeah. So right now it loads all of the meshes inside the FBX file. So let's open Blender and let's add a series of meshes here just for testing. Let's create a mesh here where we extrude this and extrude this and extrude this, and then something like this, I guess. This is our mesh 1, and then let's add another mesh here. And let's hide the old one, and let's do some editing on that. Let's do like this, and let's export the FBX, and let's set our C as forward here, and let's triangulate faces since we're not using quads. And let's replace that. Okay. Now we should see, hopefully it exported them both. But let's see, let's add a breakpoint here. And yeah, we have several meshes, I think. Yeah. So the first one has a vertex count of 87, and an index count of that. And then the next one, of course, has the offsets and stuff like that. Okay, so everything gets loaded. Let's see. So we have our model here. I'm actually unsure if which one is which. Yeah, definitely our shadows are not right, but that's not the point of this tutorial here. Okay, so when we do, yeah, we will fix the shadow stuff since we're implementing shadow mapping. Okay. Let's see our draw call, draw floor. Let's do second one. Let's not draw a floor. And then we have the planar shadows here. Let's not draw any of this with our shadows. Okay, so we won't be drawing shadows. And we can see that we have two different objects. I remember this being different. If we look into this, we have this one, and then we have the L. And this is obviously a non-uniform L, and the other object is something different. So it works. Yeah. So we can load several models now by simply creating a Blender scene with several models and use FBX to actually upload that to our GPU and compile some draw calls um, in a sort of mesh database. So yeah, uh, right now our what do you call it? Our shadows are messed up, but since we're moving this renderer in a different direction than it's previously been in, I won't mind. So yeah, we fixed the problem that was happening in the previous episode where we had to recompile the unique vertices when we load our model. That we do. So now we end up with, for a box, we end up with a total of 24 vertices and then 36 indices, which is something you would expect from a cube that has vertex normals. All right. So this is actually part one of the FBX part of this series. So next we will create some deferred rendering, and then we will move on to shadow mapping. Yeah, if you found this helpful, entertaining, or inspirational, please consider commenting, liking, or subscribing. Check out the description down below um, um, in order to figure out either to how to get the code or uh, join the Discord server or support the channel. Anyway, thanks for tuning in this episode, and I'll see you in the next one. All right, so that's it for the um, FBX code, I guess. Let me upload the video. Let's see. Let's see. Let's see. And let me edit the old episode, I think. All right, let's see. So I'm just hanging out a bit here. Any questions or comments or anything so far from you subscribers? Let's just create a small scene here in our Blender thingy. So let's actually hide these and then object mode, add a lane, I guess. Yeah, let's do 25, 25, 25. And let's uh, let's see, let's move the object here. Uh, Not volume, face nearest, I guess. Okay. Uh, oh, I had something like, didn't I? There we go. For some reason. And let's move this model as well. There we go. And let's export this scene here. Can I move it up? Ah. Let's see. YouTube tutorial models. Okay, let's see. How many models do we actually load then? We should get 3. Maybe if I do draw a floor here. That doesn't work. Let's see inside the draw data here. Meshes 3. Doesn't it work? Maybe I have an overflow. It should render a floor. What happens if I swap and this one? Oh, this is the shadow pipeline, so let's disregard that. What happens if I change this to a 2? It won't draw anything. So maybe it's because it's a plane. It doesn't like that. Or maybe the buffer is just not big enough. Let's see. Let's see. 64 kilobytes here. Let's try that instead. Okay, it doesn't like the plane for some reason. Let's see, open recent. Let's try rotating it. Let's see, and triangulate faces. Yeah, it doesn't like it. Okay. So the plane is not something that it likes. Okay. This set is supposed to be very low then. Let's do 20, 20. Plane, floor. Let's do that and then export it. And I did check the stuff right. Yeah. Okay, let's see if that works. Yeah, that works. Okay. Okay. let's commit this to the Git. Part 3, parsing unique vertices and draw data plus disabled shadows. All right. So should we get running on the whole should we get up and running on the deferred rendering stuff? So let me just do a quick break. Also, I'm thinking that we should probably update the README as well. Is it in? No, it's not. I'll have to update that manually. I need to edit this. Let's see. Commit structure. Let's see. Whoops. Let's see. So okay. So I was working on the README here. Let's see. Mm, let's see. Can I change the name of the actions? Can I on GitHub change the name of the commits? Uh, and it for some reason it doesn't save the solution or what? Can I? No, it doesn't. Uh, let's Let's see. Let's see, solution. Okay.